This video is about acid-base nomenclature. So acids are named based off their anion. All acids have hydrogen as their cation. If an anion is an element from the periodic table, then the prefix has to be hydro and the suffix has to be ic. If it's an acid, then it has to have acid at the end. So as an example, if you have HCl, you can tell it's an acid by the fact that it has hydrogen in the front. So then you put hydro, chloric, and then acid at the end. Hydro for the hydrogen, chloric for the chlorine with the suffix of ic with acid. If an anion is a polyatomic ion, then the suffix is changed. If the suffix was ate, it turns to ic. If the suffix was ite, it turns to us. The acid will still be at the end though. You can remember this by thinking of it ate something that was icky, and then just remember that the other one is ite to us. So for these two is an example of what happens. HClO3 and HClO2. This one came from chlorate, while the other one came from chlorite. They change to, over here, chloric and chlorus. If you don't put this in, your answer will be wrong. So be very careful about which one it came from. Bases contain hydroxide, which is OH, -1. As the anion follow normal ionic nomenclature rules, this one is slightly easy. So for an example, you have NaOH. The OH symbolizes that it is a base and therefore must end in hydroxide. And then the Na, you just have to put what the name is. So Na is sodium hydroxide. This is a list of all the strong acids and strong bases. If it is not a strong acid or strong base, then it is a weak acid or weak base. Let's go to some examples. So for this example, we have carbonic acid. The acid gives away the fact that this is an acid, so it has to have a hydrogen for its first element. If you go to the periodic table, hydrogen is an A1 and therefore has a +1 charge. And we'll write the charge down just so that we don't forget it. Carbonic is a compound that has multiple elements in it, so we have to go to our polyatomic ions and find it. The fact that it ended with ic means that it started with 8. So we can see that carbon 8 turned to carbonic, and its original was CO3 2 negative. Now we will combine the elements and switch the charges. So we will have H2CO3. Now if we go over to our table and look in the strong acids, we will see that H2CO3 is not in the list. Therefore, we know that H2CO3 is a weak acid. See, we have the OH, which means that it must have hydroxide, and it also means that this is a base. The Ca represents calcium. So we find calcium on the table. Since it is in the first two rows, its name stays the same. Now we have to find out if calcium hydroxide is a weak or strong base. If we go over to the table, we see that calcium is here, so it is a strong base. That concludes today's lesson.